by. Eric, I have a question for you today.
As they say, why is this day different from all other days?
Thank you so much for taking my questions um,
My,
so so graciously.
my pleasure.
So one of the things that I think I have trouble with, and others made as well, is kind of wrapping my mind around what kind of understanding do I need to have about the scale levels involved when we're talking about your theory, because we're going from strings to cosmological, and where am I in all of this? How can I figure that out?
Well, let me try to count the ways. Um, First of all, the theory about what the scale of the cosmos is not new to me. What I have tried to do is divide it down into manageable chunks. And let me explain what the problem is with one very simple example. Uh, you are, I don't know, 2 meters tall, maybe something like that, a couple of meters. And the universe is huge. The solar system is enormous. The galaxies are a million times larger than the solar systems. And the universe is a million times longer than galaxies. So, I mean, galaxies are enormous. They are a million times larger than you are.
Hmm.
But after all of that, guess what? How much larger are you than the smallest thing in the universe? You are a million multiplied by another million, multiplied by another million times larger than that. In
Okay.
fact, you are closer in size to the whole universe than you are to the smallest thing within the universe. And you're a trillion times closer to the whole size of the universe than you are to the smallest size within it. And while we have done all of the looking outwards, because that's what we can do,
Yeah.
we have done very little of the looking the other way because we can't get very far.
Mm.
If we go down a million times, we're looking at atoms. If you go down a million more times, you can barely see it because you're talking about the size of electrons. And then you have to go down a million more times, a million more times, and a million more times until you get to the smallest size in the universe. There's no way of seeing those things. The You can build these enormous colliders like we have done in between France and Switzerland, and we can get a indirect glimpse of something about a million times smaller than the electron, because the electron microscope is the thing that can see the most, and that is only 3 times a billion smaller than you.
Mm.
Now, I decided we've got to put this into some sort of a scale.
Yeah.
And surprisingly, as I started doing this, I found out if we divide everything in the universe, starting from the smallest thing that can exist in the universe, the Planck size, going all the way up to the universe as a whole, it is a million times a million times a million. That if you multiply a million by itself 10 times, you will go from the smallest thing to the largest thing.
Mm.
Now, for people who know something about mathematics, this is nothing more than a logarithmic scale base 1 million. Now, nobody's ever tried a logarithmic scale base 1 million, but I'm not inventing anything new in mathematics. And if you don't know what a logarithm is, it doesn't make any difference. Might be better off not knowing.
But it's a nonlinear proposition.
It's a very, very nonlinear proposition. And as I say, if you take the smallest thing in the universe, the Planck size, okay, there are parts, you believe it or not, the these the the tiny gap between 1 and 2 Planck sizes contains 95% of all the mass energy in the universe, and the rest of it is 5%.
And
Everything yeah,
that's what we see. The 95% is the dark matter.
it's dark matter, it's dark energy, it's dark this, it's dark that, but you cannot see it. And it is at the smallest possible scale of the universe. But that's where all the mass energy is. And we need another conversation to tackle that one.
Ah,
Uh, but if you then go 1 million times higher, there are no other particles other than particles of energy all the way down there. You have to go 1 million times higher than that, and you are at the size where you need a high energy collider, such as the one that is in between, takes up half the real estate of France and Switzerland,
mm,
and you can get an indirect glimpse of that. Then you can go 1 million times higher, and you're up at the level of an electron. Now, an electron microscope can look at everything above it, but you're already 3 scales of 1 million up before you get to an electron microscope. And then an electron is roughly 1 million times smaller than an atom or a molecule. So the next scale is the atomic scale.
mm,
After the atomic scale, believe it or not,
mm,
comes the biological scale. And that is where all biological life, from the smallest microbe that inhabits your body to the largest animal that ever lived, is within a scale of 1 million to 1.
mm. Wow.
Okay, it's one of the 10 scales, and that is all that it is. And then if you want to go back there, beyond there, you come into what we call the solar scale, which is all of the size of the planets all the way up to the sun. And then the next scale is a solar system, which is the sun and all of the things that revolve around the sun. And that's an enormous amount of things. It takes light a million years. It takes light 1 year to get from one end to the other. And then beyond that scale, which is the scale of, I think, 7, is the scale of a galaxy, like the Milky Way galaxy that our sun is part of. And
Okay,
then
stop a second because I don't want to get lost. We need to write this out in the book. Let me see if I have it. Planck length, right, is over here. And then you have to go up 1 million before you can get what the colliders are measuring.
correct,
An additional million times over that size scale increase to get to electrons.
correct,
Now another million size scale above that to get to atoms.
right, and molecules.
And then from there, another million to get to me.
Exactly. You are near the top end of the biological scale, and the microbes that inhabit your body and mine are at the other, close to the other end of it. But it is all one cosmic scale. We all fit within that cosmic scale. Then all of the heavenly bodies of any size at all fit
Then
into
we have to
the
start
next
going up.
scale. And
Yes.
that's the largest single element there is. After
So from
that,
E to planetary scale, another million.
correct. And the solar system scale is now the sun and everything that revolves around the sun or any other star, and that is 1 million times larger than the sun itself.
Okay.
a,
And
a
then we have to go
million
up.
again. And now
Yes.
comes a galaxy.
So another million.
Another million times. Now, let me tell you a very funny story about the galaxies. The galaxies have roughly 1 trillion stars, the ones that you can see,
Mm,
but they are a million times further away than any star in the Milky Way, in the, excuse me, in the in the
solar system?
in
No.
this in yeah, any star
Uh,
the size of the solar system, and
mm,
and other stars. And when you look out at the heavens on a clear night away from the city lights,
yeah.
you can see something that looks like the Milky Way galaxy, and it is full of stars.
Yes.
Now it's very funny because half of those stars are actually galaxies that
Wow.
are the light of it, the combined light of 1 trillion stars, but they're a million times further away, and
Way.
they look like a single star. So
Uh,
half the stars that you're seeing are galaxies.
galaxies.
If you've ever wondered how can these books about the universe have so many galaxies, well, half the things you're seeing in the night sky on a clear night are not stars at all. They are galaxies, and to the naked eye, they look exactly alike. But even a modest telescope would show you that they are, in fact, not single stars. They are galaxies. They're
And
galaxies.
then my scale level where I am now is closer to those remote galaxies that look like stars than it is to the Planck length.
You are absolutely correct. It's close, and not by a little bit, but at least 1 trillion times.
Gosh.
Now, a trillion is exactly the same size. Also, if you want another comparison, if you take the smallest microbe that inhabits your body, you are a million times larger than that microbe,
Okay.
and the Earth is a million times larger than you are. So you're comparing the size of a microbe that you need a telescope to the universe. That's 1 trillion to 1. And
Wow.
that is a tiny part of the cosmic scales. Now, you have to understand what the cosmic scales are, because otherwise you think you're talking about a microbe, and you're talking about the Earth
Yeah. Yeah. So,
if you don't understand the difference.
and then a trillion is
A
a
million
million,
times a
million,
million.
million.
Yeah, a million multiplied by a million. And if you're scared of large numbers, there is a name for this fear of large numbers. I've forgotten it, but you'd better get over this before you read too much on cosmology,
I
because
like that.
the
Get
numbers,
over it.
yeah, the numbers are mind-boggling.
Mm.
And you can't even think about it without dividing it into compartments. And the reason why it divides into 10, I have no idea, but it's a nice number, and I'm happy with it. And so I've invented the 10 cosmic scales,
Oh, all right. All right. And we've gone through them.
and we've gone through them, and in the book they're explained in much better detail than you can in a 10-minute video.
I don't know how you're going to chart it out. You're going to have one of those fold out pages.
It's going to be a lot of folds.
Thanks so much, Eric. It's always great to see
You're
you.
very welcome.
Take care.